So, Ted, you were saying last time that after a big star has exploded, it can become a black hole, but also something else?
Yes. So if the star is really big, it can turn into a black hole. But if it's not quite so big, but still about 8 to 20 times bigger than the Sun, then it turns into a neutron star.
So what's a neutron star like?
A neutron star is very small, only about 20 kilometres across, compared to the Earth, which is almost 13,000 kilometres across. This means that it's very dense, as there is a lot of stuff squashed into a small space. For example, here on Earth, if you had a spoonful of neutron star, it would weigh as much as everyone on the Earth.
Wow, that's so cool.
Now that's not the end of the story. When the big star's core is collapsing after the supernova, it can rotate as it falls in on itself, spinning faster and faster. This is a bit like an ice skater spinning, and when they pull their arms in, they start to spin faster. The spinning star speeds up the particles around it, and these give off beams of light. Because the star is spinning, the beam of light spins around too, much like a lighthouse light. So to us, the star appears to flash on and off. Neutron stars that pulse like this are called pulsars. After a while, the star's spinning starts to slow down, as the spinning energy of the star is used to speed up the particles to very high energies instead. The fast particles get trapped around the star and spin around with it. At very far away distances, called the light cylinder, however, the particles would have to travel at the speed of light to keep up with the spinning pulsar. It's a bit like on a big merry-go-round, where you go faster if you're sat on the outside to keep up with the people in the middle, as you have to travel further in the same amount of time. So because the particles can't go faster than the speed of light, they break free from this area around the pulsar and stream away, becoming what we call a pulsar wind. This pulsar wind is really fast, and it bumps into surrounding material in space, creating a shockwave where particles are sped up. This then spreads out as a cloud, which we call a pulsar wind nebula. A really well-known pulsar wind nebula is the Crab Nebula.
Wow, it's so pretty. I can't believe how much stuff is going on out there in space. So Ted, do you look at these things? What is it that you're looking for?
Well, we have pictures of pulsar wind nebulae in all sorts of colours of light, like microwave and X-ray, but not such good pictures in gamma-ray light. So we're trying to get really good pictures of these nebulae in gamma-ray light. This should help us be better able to understand what's going on inside them, like what goes on with the particles inside the nebulae. Also, we should be able to see more pulsar wind nebulae than ever before, and get a better understanding of how they grow and how they affect the places around them.
Oh wow, that sounds really exciting.